In this lesson, we look at summation notation and factorials. Starting with factorials. For any positive integer n greater than or equal to 2, n factorial equals n times n minus 1 times n minus 2 times all the numbers in between until we get to times 3 times 2 times 1. 0 factorial is defined to be equal to 1. 1 factorial is also defined to be equal to 1. As an example, 4 factorial equals 4 times 3 times 2 times 1, which is equal to 24. Summation notation. Given a sequence, the set of a sub n from n equals k to infinity and numbers m and p satisfying k less than or equal to m less than or equal to p, the summation from m to p is written. The sum from n equals m to p of a sub n equals a sub m plus a sub m plus 1 plus all terms in between up to plus a sub p. The variable n is the index of summation. The number m is the lower limit of summation. The number p is the upper limit of summation. Evaluate the following. The sum from n equals 1 to 4 of n factorial. We start by plugging 1 in for n. So we have 1 factorial. Then we have 2 factorial. We put 2 in for n next. Then 3 in for n, 3 factorial, plus 4 factorial. We stop when we get to 4, the upper limit of summation. We evaluate. 1 factorial is 1. 2 factorial is 2 times 1, or 2. 3 factorial is 3 times 2 times 1, which is 6. 4 factorial we found to be 24. And when we add these numbers together, we get 33. Let's find the sum from k equals 2 to 5 of 2k minus 1. We start by plugging 2 in for k, so we'll have 2 times 2 minus 1. We next plug in 3 for k. We have plus 2 times 3 minus 1. Then we plug in 4 for k, so we have 2 times 4 minus 1. And last of all, we plug in 5 for k and have 2 times 5 minus 1. Okay, so simplifying, this will be the same as 3 plus 5 plus 7 plus 9, which is equal to 24. Next, we'll rewrite using summation notation. 2 plus 3 halves plus 4 thirds plus 5 fourths plus 6 fifths. So it looks like n will be 1, 2, 3, 4, 5 here. So we have the sum from n equals 1 to 5. We just need to figure out what we're taking the sum of. Well, it looks like we have fractions in each case except for the 2. And I can rewrite 2 as being 2 over 1. Once I do that, I can see that our denominators contain the n values here. So I can just let the denominator be equal to n. And then each numerator is equal to the denominator plus 1. So we'll have the sum from n equals 1 to 5 of n plus 1 over n. Try on your own. Find the sum from n equals 2 to 6 of n over 8.